Hey guys, and welcome to our containers tutorial. Today we will talk about the advantages of using containers, interfaces, exposing, and the repository in your Ventuz scenes. So first let's talk about the two types of container nodes that exist in Ventuz. On the one hand, we have the content containers. They simply group several content nodes into one single node. Like in our example, this one loads an image file, adjusts its hue value, and provides it as a texture so we can use it on our cube. On the other hand, there are hierarchy containers. They group several hierarchy and content nodes into one single hierarchy node that can be used as any other. So this one here has an animated axis node and affects the cube that is a child of it. Both types of containers may expose input and output properties of its nodes so that they are accessible from outside that container. To do so, just click on this little square over here so it turns green. As you can see, you can now simply bind those properties like any other property of any other node. So to bind the texture we just created to this cube, just take the texture property of our texture node and bind it to our own content container. So now our texture that our content container provides is bound to the texture property of our cube. Also, you can turn interfacing of your containers on and off. It's in the properties window down here. When you do so, it is much easier to handle several similar containers because you can apply any change you made to one of them to any other of them by just dragging and dropping them. So now let's discuss the advantages of using these features of the container nodes. We will try to show the values of an array node with multiple 3D texts on our renderer window, but we will make it as flexible as possible because we don't know how many values the user of that presentation wants to show on screen. First, we will need an array. So let's say the range is about 5, and we will add some random numbers to it. To access a single value of this array, we will need a float array indexer. So as an input, it gets the array of ours and provides the single values of them as outputs. As a second input, the array indexer has the start index. So as you may have noticed, the first value of our provided outputs is always the value of our start index. Just keep this in mind because we will use this later. Now add a 3D text node to our scene. You can bind the text property of our text node to the first output of our float indexer. So when you change the start index, the number changes accordingly. We could now simply copy and paste those nodes and rearrange them to achieve our goal, like this. But instead, we want an automatic way where we simply have to copy and paste those nodes and let Ventuz do the rest. To do so, we will first need an arrange node. This node arranges every direct child of it on the specified axis and the offset. So let's say we want a center chain and an offset of like 0.5. When we now copy and paste our nodes, you will see that it will be arranged automatically. But as you can see, the numbers still stay the same. Now our hierarchy container comes in use. We will want to bind every node that affects a single text of ours into one hierarchy node. So let's unbind this float array because it is global, like this, and right click on our axis and say merge to container. You could instead simply drag and drop a hierarchy container in here and copy and paste the nodes into it. You may now rename your container so it is recognizable. Let's say number 0, and get into it by double clicking on this little gray arrow over here. In here you can see your old nodes. So Now we have to expose the array property of our indexer node, since when we now change the array outside the container, it won't affect the indexer, so we will have to rebind it. Go outside and you will see the input over here. Just bind it as any other property to the array node. Now we can simply copy and paste our hierarchy container node as often as we want. But first let's turn the interfacing on, because maybe we want to make some changes later that we want to apply in an easy way. So now right click and drag it directly below itself. Click more and check keep same source nodes and make 4 instances of it, so we have the 5 numbers of our array. We could still simply set the start index inside all containers manually, but there is a much more elegant automated method. So let's get inside our first container again. Here you can place a container info node. It has several information about our container that it is placed in. For example, the name index. The container info node will search for a number inside the name of our container it is placed in and provide it as an output. As you can see, our containers are numbered from 0 to 4, just like the indices of our float array. So now we can just bind the start index property of our indexer node to the container name index property of our container info. When we now copy those changes to our other interfaces, you will notice that they now change to the according numbers. You now have a little node that displays a number or a string of an array as a 3D text on screen. You could use this node in other scenes as well. To do so, open your repository over here. This is your project repository, and you can add some nodes that you want to use in other scenes by simply dragging and dropping them into them. You can change the name of the node, the hint text, the icon, and so on over here. Also, you can now bind your nodes to a completely different array that is much longer than our first. So this has 5 elements and this has 10. You will have to delete those, unbind your first container and bind it to the new array. Now when you repeat the procedure of copying it from earlier, you will notice that this still works perfectly fine. That's it about containers and their features and advantages of using them in your scenes. So I hope I will see you next time when we will talk about simple animations in Ventuz.